When is impulse conserved? Impulse is generally conserved when the net force, or the applied external force, equals zero. One may ask why such a system would become zero in terms of force. And the answer would be simple. Here is the answer to it: when all the forces acting on the system under motion appear to be balanced in all possible ways, then that particular system is considered zero. The balancing of force happens when the directions are in different ways, and the magnitude of the force seems to cancel out. Since the system has zero net force, the impulse is usually zero and conserved. When a force is acting on the body, it will have direction and magnitude as well. It will tell us how much and how far the object has been under motion. Is impulse conserved? Yes, it will be only when the net force is arrow acting on the body. Whenever we talk about a body under motion, we consider as many factors contributing to it. Newton's laws are one of the most helpful laws that are handy when we consider a body under motion. So the impulse is more like the amount of force with which an object is said to be moved. We all know that the force is one main thing, or a factor, that is the only responsible vector that allows a body to be in motion, abiding by almost all three laws of Newton. So when all these forces happen to be balanced in any particular system under motion, the result will be that impulse is zero. In more convenient thought, the impulse is conserved when the net force equals zero. How is impulse conserved? Yes, the impulse is conserved in a system only when the inertial frames of reference have the same magnitude. Like when we say that a force is responsible for the motion of any object under gravity, we need to know that it has both direction and magnitude as well. Generally, when we talk about the inertial frame of reference, we talk about the body that is not under any constant motion with velocity and changing with time. The non-inertial frame of reference deals with the body that is accelerating. So when the body is under motion, we must know the factors that contribute to its continuity. Impulse with the same magnitude where the direction is negligible will be conserved. This conservation is related to the momentum as well. It is standard information that the side effect of conservation of the energy results in conservation of momentum. When momentum is conserved automatically, the impulse is also conserved. The momentum is zero before and after a particular process. In both these conditions, the impulse will be conserved due to the body being under rest and no longer accelerating. This condition explains better how an impulse is conserved. Why is impulse conserved? When there is an object undergoing motion, it will be at that same speed with the time until an external force is applied. When the speed changes, it gains acceleration. This acceleration is the change in velocity with time. During a particular collision between any two objects or particles, that system will experience a change in momentum. That is, the mass will be in motion, and the force that acts will be measured by impulse. We all know that impulse changes the momentum when the force acts on a body with a constant time variation. It is tedious to calculate the force with constant change in time. So the formula of impulse comes to the rescue. When the collision happens, those participating in the very process will encounter a change in momentum and impulse. So when the momentum is conserved, the impulse will by itself conserve. When the object experiences an exertion when the force is applied, it is called an impulse. This impulse usually happens when there is a change in momentum in the object or a particle, we say. So this is why impulse is conserved when the momentum becomes zero. Is impulse conserved in an inelastic collision? The most dealt question in this topic is impulse conserved. Yes, impulse is conserved in specific ways, and we shall dive directly into it. Impulse is conserved in any system, whether it is elastic or inelastic. Generally, when the individual body has momenta, it will experience a change in momentum despite the process being elastic or inelastic. So the impulse is just an exertion on that particular body. So it will automatically be conserved. Force acting on the system will be changing with time, constant change in time. So the net force is unbalanced. Hence it will be there not being negligible. This force exerts an impulse on the body under motion. It will, in turn, show an impact on several other factors that has an equal impact on the body under motion. In an elastic collision, the system's kinetic energy is lost, and hence the momentum will be conserved since the energy is converted into another form. In an inelastic collision, when two particles collide, they undergo a process where the kinetic energy is lost eventually and converted into some other energy. Here energy is not conserved, but the momentum is conserved, hence the impulse is conserved. Is impulse always conserved? No, the impulse is not always conserved because only if the net force acting on the system appears to be zero will the impulse be conserved. If all the forces of the system are not balanced, then the net force acting will still be intact and will not be equal to zero. This way of net force not being equal to zero will keep the impulse non-conserved. When we talk about the conservation of impulse, we simply talk about the quantity of force applied to the object over a particular period. Impulse is zero in a system before the collision because there is no force acting on the system, nor is the system at motion. Hence there will be no place for the impulse to happen. And therefore, the concept of any conservation is not possible. But when a system is under motion or most promptly, after the collision, the system has been under the influence of force which exerts an impulse on it. There will be a change in momentum, which is the impulse itself. When is an impulse not conserved? Impulse is not conserved when the body is at rest. Probably when the body is under motion and when the momentum is not conserved, the impulse is not conserved. The total force acting on the body over a period of time will exert an impulse over the system. The impulse comes into action whenever the momentum of a system changes. Since the impulse simply is the change in momentum of a system when a required amount of force is applied, that system changes time over a frequent period. We now have a clear understanding of how well impulse works on a system at rest and in motion. In both these conditions we must be aware that an impulse is an active response with only the force applied to the system over time. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.